Hello, we're going to be taking a quick look at our TekExpress DDR-TX automation software solution relating to LPDDR5. So when you first open up the software, you'll be taken to this landing page. And the first thing I want to draw your attention to is on the left side of the screen, you'll see these set of steps you can go through, and it's going to really help you and guide you through setting up both the software and making sure your hardware configuration matches what the software expects so the data you're taking is actually relevant and of interest to you. On this first page here, we're setting up some characteristics about our actual DUT. So first we can choose whether to select live waveforms or pre-recorded waveforms. We're going to be doing live waveforms today. We can also rename our DUT and make sure LPDDR5 is the selected device. Just below that, under device profile, we can select a data rate from a predefined list or a custom one if you're outside that range. We're going to set it back to 3200 though. Just to the right of that, you can select your write clock to clock ratio. And below that, we have our burst detection method. So the main one we're going to be dealing with is read and write bursts. And what this does is it separates reads and writes if they're in the same acquisition, and the software can identify which is a write burst and which is a read burst, and then apply the relevant measurements to those bursts. This is going to be really important as far as taking your measurements in LPDDR5. If we look at the waveform real quick, we have a write burst on the screen. You can see on the left side of the waveform here, we have our preamble. And on the right side, we have our postamble, as well as the center where the DQ, our blue signal here, and our write clock, the yellow signal, are overlapping and the burst data is actually being defined. We can also see the delay between the start of that and when data actually starts. If we go back over to our burst detection method in our setup, we can see that we can input those same parameters into the read and the write settings. These two tabs are going to be completely independent from each other, so don't worry about overwriting settings if you're altering one or the other. We also have our reference levels here at the bottom of the setup page, and these are going to be only used for burst detection. By default, they're auto, but you can switch them to manual and input your own values. Don't worry about these changing your measurement results because the settings here in this setup panel are only used for identifying and separating bursts. Now that we've set up this main page, let's go ahead and select test selection and take a look at some of the tests. By default, we categorize our tests into three categories, being clock, data strobe, and our CA and CS tests. Since we're looking at a write burst today, we're going to go into our data strobe, write burst, and let's select some tests. At the bottom of the page, you also get a short description of what the selected test actually entails, and you can take a little bit of a closer look at what you're actually going to be measuring. Going into our third step here, it's the acquisitions panel. It's at this point you need to let the oscilloscope and the software know what channels and what signals are present. So in this case, we're going to be using a DQ signal and a write clock signal, and I have those assigned to both channel 1 and 2 in our physical setup, so I'm going to match that in our software selection. Next, in our configuration tab, we're going to get a couple different settings here. On the left, we have global settings. These are going to influence every measurement and every test you've selected. You can change things such as the default bandwidth of the system, the record length, and the sample rate. If we go over to the Measurements tab, we're going to get settings that are unique to that acquisition group. So this write data acquisition here has been enabled because we selected set tests for those write bursts. And these settings are going to be unique to that. We have some reference levels that we can control, which are actually going to impact your measurements in this case. This is separate from the burst reference levels we looked at earlier. These will actually change your measurement results if you go ahead and alter them. In the Analyze tab, we also get some unique settings relevant to the set of tests we've selected. Since we're looking at an RX mask and some of the measurements associated with it, we have some options related to that. We can choose to superimpose the write clock on the back of the eye, as well as scale it to either DQ or the write clock. Let's go ahead and scale it to DQ. We can also have some additional options such as stopping the test if there's a mask hit, or looking at a specific number of UIs, or if we disable it, just the entire acquisition. We can choose to include some margins in the plot for additional details on the actual eye diagram, and even edit the actual size of the mask itself in terms of UI and voltage at the bottom here. Lastly, we have our Preferences tab. These are just going to be some nice ease of use options that you can control once you get a little bit more used to the software, such as enabling additional logging or choosing how you want to deal with pop-ups, if you want them to auto-close or not after a predetermined amount of time, being able to set up email on failures or other notable events, and a multi-run feature, which whatever number you input here, we're going to get that many amounts of unique acquisitions and then apply all of our selected measurements to those unique data sets, however many times you input. Now that we've kind of gone through our walked through guide here of setup steps, I think we're ready to go ahead and start the test. Initially, TekExpress is going to minimize into a smaller dialog box that still contains a log view of what the software is actually doing on the scope. If we hit this button on the right side of the box, we can go back to our larger view with the log expanded, and we can also go ahead and take a look at the test status as well. To minimize it again, just hit the same icon. Going through, you'll notice the scope has set itself up, and at the top of the screen here, we can see these purple arrows indicating the bursts that we've identified as writes. We can also see the scope plotting the eye in real time. Once our tests are complete, a automatically generated report is opened by default. And at the top of this report, you can see some summary information such as the test time, the software version, the device ID that we named earlier, the date of the test, etc. As we scroll down, we'll get some more detailed information about the measurements we specifically selected, such as the actual value, its limits, margins, etc. At the bottom, we'll see our mask that we decided to plot. And we can note here in this case, we are not using de-embedded signals, so it's a bit messier than we'd like to see. And maybe de-embedding was something we can look at now, having this information. We can also see the additional margins that we requested to be applied to the plot back in our configuration panel. Maybe now that we've looked at this report, we want to do some little bit debugging and take some further analysis on some of the signals. A good way to do that, if I go back to our initial DUT page, is this user-defined acquisition mode, or known as UDA. If this is enabled, what's going to happen is the scope's not going to take over once you hit the start button and do an auto set and try to maximize the signals for the test. It's going to instead use whatever acquisition signals you've manually input into the scope. This can be especially useful if you want to use your own settings for further debugging in the sense of vertical or horizontal or any other scope acquisition settings that can be controlled. It's going to use those instead of a default and auto set. With that said, that's been a quick overview of TekExpress DDR-TX relating to LPDDR5.